Okay, so this one's gonna be another one, but with Fischer projections. Um, Fischer projections. Just keep in mind that Fischer projections um, look like this. They look like that. But we just draw them as sticks. So whatever on the edges is wedged, whatever on the tops is dashed. All right. So we have to keep that in mind when we're thinking about fourth priority type of stuff. All right. So other than that, everything else stays the same. There's nothing else different. It just looks a little different, right? So don't let the way it looks intimidate you. Okay. So we're gonna go to this one. We're just gonna um, go here. We'll start there. O is 1, right, according to our priority rules. Okay, and now 2 and 3, again, we have a tie. We have a carbon here and a carbon here. So we got to now, because they tie, because it's just a carbon, right, we're looking at direct connections from here, directly connected to this carbon, directly connected to that carbon. We're looking at just direct connections. Now we have to move to those carbons and see what they're attached to. This one's just attached to an oxygen. But this one is attached to an oxygen, a carbon, and a hydrogen. So oxygen, oxygen, that's a tie. But because it's just an oxygen, the fact that it's connected to even more, even if it's just hydrogen, means this is gonna be 2, right? So I said that this and this, right? That's a tie. Those are both oxygens. But there's more on this carbon. There's a carbon and there's a hydrogen. So this one wins out. So that's gonna be 2. Then this is 3 and this is 4. And we ignore 4 when we're doing the arrow thing. And it's 1 to 2 to 3, so that's going to be S. But now we go to number 4. Where's number 4? Number 4 is here. What I said before is on the edge, it's really a wedge. So 4 we're going to flip, right? Because 4 is in the front. So this one's going to be R. Now we're here. O is, hold on, I'm just going to erase all these because it's kind of getting messy. O is 1. This one's 2 for the same reasons the last one is. 3, 4. Now 1 to 2 to 3, that's R. But 4 is in the front, so that's S. So this one from top to bottom is top, we have an R. Bottom, we have an S. Okay, sorry, I don't want to move too fast, but you guys can pause this. So let me just go through this again. So 1, and then 2. This is from this carbon. Then 3, right? We said 2 was the way it was because when we moved to these carbons, because we had a tie, we saw that this one was connected to an oxygen. This one was also connected to an oxygen, but when this top one had no more connections, this one still had 2 connections, right? So it weighs more, okay? And then, and so 1, 2, 3, and then 4, right? So we did our RNS, which was S, but we have to keep the same rules, right? If 4 is in the front, we have to flip it. And with Fischer projections, what's on the arm, right, is always wedged. So if 4 is in the arm, we flip it. So that's why that's R, okay? So top's R, bottom's S. Now we got to go over here. I just do this to keep track of what is what. Top, 1, 2. So what's nice about a lot of these is that if it's the same structure, you can kind of use the same ordering system. You just have to flip it, right? So that's 1. We know this one's 2 because of the tie. 3, and then 4. So 1, 2, 3, that's R, but 4 is in the front, right? So it's S. So the top is going to be S. So the top is going to go right now from R to S. Now we got to see what this bottom piece is talking about, okay? If the bottom stays at S, then we have a diastereomer. If it goes to R, then we actually will have an enantiomer, okay? And so I'm gonna explain how to know how do you tell it's an enantiomer, okay? Okay, so from this one, we got 1, we got 2, we got 3, and we have 4. We ignore 4 when we count. 1, 2 to 3. That is S. But number 4 is wedged, so that's going to go to R. So the bottom's going to be R. Okay. And this is going to be an enantiomer. Why? Enantiomers always flip from one to the other, is what I mean. They go R to S, S to R, 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 S, S. Every chiral center flips. Right? Here's what I mean. Like this one went to R to S, S to R, R to S, R to S, S to R, R to S, R to S, S to R. Every chiral center flips. Every single one. Right? And so that's an enantiomer. Okay? While, remember I said beforehand, if this one stayed S, it would be a diastereomer, right? Because everything is the same except this one. Okay? Also, if nothing changes, it's the same compound. If nothing changes, it's the same compound. Okay, that's another thing. Right? Okay. So that's just how you do the RNS for Fischer projections.